And what this is going to do is basically create an anchor offsets for teleporting our camera back to a target object. So let's do that right here by accessing our global transform. And as you can see right here, it does not have a global transform because this is extending from a common node. Now we should have one. And as you can see, there it is. So our global transform is going to be equal, and actually it is our origin global transform because we're not setting the transformation, only its position. It's going to be equal our target node global transform origin plus our anchor offset. So what this is actually going to do, if we run this scene, and I don't think we have set up our target, let me just double check. So on our main scene here, and we can actually close these ones. Let's select our third-person camera. Let's assign our human character. Now whenever we run the scene and we move our object, you can see that the camera is going to move along with it. If we do not assign this code and we run it, you're going to see the camera is not attached to the object. So the camera is following the object itself. That is why we want to pass a export variable called target node, which is up here, as we assign it back on. So now let's take care of the rotations on the Y plane first, so it keeps the tutorial a little bit simpler. So let's create a couple of new vars here. The first one I'm going to be creating is the input rotations. And this is going to basically store all the input rotations we're going to be getting from the player output. And then we're going to be later assign it back to another variable which we're going to call rotation XYZ. And this is going to be a vector we're going to apply the rotations of our node structure back towards to. So this is going to accumulate the rotations from the inputs, and we're going to process them under this variable here. So let me show you what I mean. Let's create here a new function, and we are going to override another built-in function called unhandled inputs. And we want to use unhandled because we want inputs not consumed by other objects. So we want to check if this event is an input mouse event motion, because we want to grab the input event mouse motion, which is basically, and not button, is motion, because we want to grab the movement of the mouse itself and not clicks. We're going to be storing that under another variable called var velocity, and this is going to be a vector too, and it's going to be our event as an input event mouse motion, and we want to grab its, I believe it's called get reminder. No, it's called get screen relative. What this basically does is grab the unscaled mouse position relative to the previous position in the coordinate system of the screen, so basically in 2D. Then next we want to assign that towards our input rotations on its Y value. We want to assign the mouse velocity X value multiplied by our sensitivity value, which we do not have. So we need a variable to control the sensitivity of the mouse rotation. So we're going to do that by creating a new variable here, and this new variable, we can actually put it down here. It's going to be our input mouse look sensitivity, and this is going to be a float, and at the moment we're going to leave at 1.0, but this basically is going to be an option inside of your game to control the sensitivity. So this is our input mouse movement sensitivity. So we're basically storing the mouse velocity as an input rotation for another variable vector on its Y position, so we know it's a bit easier later to apply it. So let's create a private method that we're going to be applying the rotation towards to. So let me declare a new function, which is going to be rotations apply. And this is going to request a delta argument, which we're going to use to multiply things. And this should be a double point, and here void, because the function does not return anything. So the first thing we want is to apply rotations from the inputs towards our rotations variable here. So we want our rotations XYZ to be added, the rotations from our inputs, which is our inputs rotations, and we want to multiply that by delta. So if we do this by itself, it's not going to happen anything because I need to call this function here. So after we have teleported our camera, we want to start applying the rotations, and it's going to ask for a delta, which is our delta from our process function. So as you can see right there, if we run the scene, we should be able to start moving the camera, and we do not have that. Why that is the case? Well, of course, because we are simply changing the rotation value of the variable and not applying it. So we need to apply the rotations. And for that, we're going to need to add our nodes. So now we're going to start applying the code back into our nodes. So let's go back to our node system here for the camera asset. And let's grab a bunch of nodes here. So I'm going to be needing the camera. So let me grab here and press Ctrl to add as a new line. And I'm going to need that. I'm going to be needing the Y rotator, the X rotator, and the Z rotator. I'm going to rename this to fit my naming convention. And there we go. Now we should be able to set it up. So now on the rotation here, let's first apply the Y rotation, which is the one we are capturing here on the inputs. So let me get my rotator Y. And let's say its rotation on the Y plane is going to be equal to our rotation xyz dot y value, which is the one we are storing up here. Of course, I put this on uppercase, which it should be lowercase. And now if we run the scene, we should be starting to see some rotations with the camera. Now, what is going on is the input is getting accumulated inside of the variable after each passing second, and if we move the mouse very quickly, it's going to spin a lot. So what we need to do is, after we apply the rotations back to this vector, which we're going to use to apply the rotations, I'm going to basically reset the input rotations. So in this case, we are setting only the Y, so I'm going to be resetting the Y to go back to 0. Now if we run our scene here, you're going to see that the inputs work correctly. However, the inputs are inverted, and we need to invert the vector grab from that. You can basically invert anything you want. I'm going to invert this one. You can also multiply by -z, or even invert how the player is grabbing it. So there we go. Now we should rotate to the right side. And this is only the Y. And as you can see, it follows our character by teleport to its origin position, and it rotates around. Now we need to take care of the up and down movements. So let's go back here and let's set this up on as input rotations. Our X value is going to be equal to our mouse velocity, Y, and we are going to be multiplying that towards our sensitivity. So what's happening here is we are starting under input rotations from a given input. So from the mouse, we want the up and down movement of the mouse to control the rotations of the X, and for the X, negative and positive of the mouse to control the rotations on the Y. So if we go back to the 3D scene here, and we grab this one, we want the left and right movement of the mouse, in this case an X. If you think about a vector, a 2D vector, want to control the Y coordinates of the rotation value of the camera. So whenever we move the mouse to the left, we want the Y coordinates to be rotated to the left. That is why we are setting it up here, as in this case, to use the X of the mouse velocity towards the Y of the rotation. The same applies with the X here. Whenever we want to move the mouse up and down, we want to control the rotation of the X of the camera, which is going to be this node. So it rotates the camera up and down. That's why it's done this way here. And I like to keep it separate so we can have finer control. Next thing here, we want to also reset the X, and we want to set it up so our X rotator is using our rotation on its axis value from the rotation X. As you can see, doing this way is pretty clear what we are doing. That is why I have done two separate variables to control. One to grab the input rotations and another to classify the rotations itself, so we can later apply it to each node we have defined for every single axis to rotate the camera. So now we can rotate up and down and move our character. So as you can see, our X value does not have a limit, so we can basically rotate wherever we want. So we want to limit the up and down rotations so it gives on a specific range. So for that, let's create another parameter here inside our private variables. And we're going to be calling this a rotation X range. So you can see that it can get quite complicated if you're not building this yourself, you're just copying code. That's why I recommend you to follow this tutorial, which is much better if you try to couple the final results. You need to understand the code. So the range that I found to work it is to be minus 0.4 towards 0.6. And this here is in radians. If you don't know, rotation values itself in Godot are done with radians. So if you want this to be converted back to degrees, say you want to specify this in degrees, there are functions to do that. You can say degrees to radians back, and here any value you type is going to be converted from degrees back to radians. And you can see on the global scope we have converted an angle expressed in degrees to back to radians. So there we go. In this case, 180 degrees in radian is this value. So Godot default rotations are put in radians, that's why this range here works. So now we have a variable that defines the range we want to use for the camera. We need to limit it on the code here. So let's, after we have defined the rotations, before we apply it to our node here, we want to limit our rotation XYZ on its X value. We want to clamp this with a float, and we're going to be clamping the rotation XYZ on its X value, and want to clamp it to our rotation and range X and our rotation range Y. So we are basically using a vector tool to create a range which we can limit our rotation X back towards 2. So now that we have done this, if we run our project, you should be able to see that the camera now has a fixed rotation. It does not pass a certain threshold because of that function. And if you want to change this, you can simply set another parameter here, and this is going to be updated accordingly. So you can see the difference is not that prominent. Let's put this a little more higher. So as you can see, we can now limit this to see upwards. So yeah, you can play with this to fine-tune towards where you want it. Now that we have this little system, let's add a zoom functionality. And I'm actually going to hide my mouse movement. So on our player code, we have this line here, we have commented it. We can simply let it run. Now we should not be able to see the mouse anymore. And as you can see, that works. So let's create a zoom functionality here for our camera. So whenever we scroll the mouse wheel, we want to move the camera around. Now we should not move the camera itself because we have a special node that detects collisions. And as you can see right here, this fine line here is the collision line. And if you move the camera outside the collision line, it's going to teleport the camera back towards the center of it, which has no collisions. So instead, we want to change the range of the spring arm so it actually extends the camera on its length. So to do this through code is very simple. Let's first detect the inputs. So here on our unhandled input function, let's create another function which, if our event is a input event mouse button, which basically means our scrolling mouse wheels are detectable as mouse buttons. So if our input pressed is a action pressed, and it is our zoom forwards and backwards, which should be down here, and this is all default commands for Godot projects. So if it's our zoom forwards or zoom backwards, we're also going to set that up, but this time we want to apply a zoom backwards. So if it is zoom forwards, we want to grab our spring arm, which I have not added as a node. So let's do that. So now we should have a spring arm. So let's say that our spring arm length, which is our spring length, is going to be added minus 0.5. And the same is going to be applied, but this time we're going to be adding it. This itself should be enough for us to create a zoom function. As you can see, we scroll backwards, it's going to zoom out, and if we scroll forwards, it's going to zoom forwards. However, because we are not limiting this range, we can basically zoom towards infinity and decrease the zoom towards infinity as well. So let's clamp these values very similar to how we did this clamp function here to our rotation. And of course, we're also going to be needing a new function to control the length rotation of our spring arms here. Let me just put this in a new line here. And let's go right on top here. And I'm going to be basically duplicating this one and call this one spring length, min and max. So it gives a little context difference towards rotation and other parameters. So I'm going to put 0.9 and 1.8. This also you can change as we want. So let me just copy this, and I'm going to be placing it under here as a reference very quickly. I'm going to copy this line of code, which we're going to be using to do the code down here. So our spring arm length is going to be equal towards a clamped value. So we want to clamp this value plus, and actually negative 0.05. And now we just pass the range, our X and Y range. This should be enough. And the same thing we're going to do here, but this time instead of deducting 0.05, we're going to be adding. And this is enough for the function itself. I could do enter here so we can see stuff. So if we press zoom forwards, we are going to grab the spring arm length. We're going to assign a new value towards it, which is going to be a clamped value, which basically means a limited value, which is our current spring length minus this value, and it's going to be limited towards our min max range on its X and Y, which is 0.9 or 1.8. And the same thing whenever we zoom backwards, the difference is we are adding a value instead of deducting it for zoom and forwards or backwards. So with this, if we run our scene, we should be able to zoom forwards at a given point, and the function no longer allows to zoom in more, and zoom backwards as well, and we have a limit. So now we can zoom backwards and forwards in a very specific way here. Now the last thing we need to do is to apply the shoulder rotations towards the camera. Now for the shoulder rotation, I'm going to do a couple of things here. So the first one is we want to rotate the camera setup itself past a given point to give that over the shoulder camera sensation. So if you see right here, the character is centralized on its Y position. So it's exactly on the center of the back of the character. We want to put it on the side, and we want to assign by which side we want. So to do that, we're going to need another anchor, and this anchor is going to be a rotation anchor. So this should be our shoulder rotation Y offset. And it's going to work almost like the anchor on top, but this time it's for rotation. So we're going to assign as a float, and it's going to be degree towards radian, which we can very simply specify a radian that's going to be a degree that's going to be converted to a radian. So we can rotate our anchor. Now the way we are going to do this is by copying this anchor here. After we have reset the rotations itself and we have applied them, we're going to do another thing here, which we're going to call the shoulder rotation. So just we separate the code, and our camera rotation itself on its Y rotation is going to be equal to our camera shoulder rotation Y offset. And what this is going to do, as you're going to see it, is going to place the rotation of the camera towards a given angle. So now we have an issue, and I'm going to address it in just a second. I just want to invert the rotation itself. So as you can see, now we are on the right side. So what is going on? Why the tilting of the camera? So this is a result of setting the rotation of the camera towards our given structure here. And we can actually see this very simple here. We first rotate our camera towards the Y, so the rest of the chain follows. Then next we rotate the camera towards its X value, as you can see here, that happens as well. But then we decided to rotate our Y of the camera, which is different to all the other rotations. And whenever we do that, we simply get an accumulated effect, and it distorts the camera. So what we can do is to reset the rotation of the camera itself after we have applied all this chain of events, but to set it up as a global one. So what do I mean by that? You can simply specify here that the camera global rotation, its Z value, is going to be equal to our rotation XYZ dot Z. So this should fix any issues with rotation itself. Of course, I put here an upper letter, it's lower letter. So as you can see here, if we do that, it should fix the issue we have here with our anchor. And as you can see, it no longer is rotated towards that. So we want to control that to our code, not let the chain of events do that indirectly. So this basically set up the global rotation of the camera to be equal to the ones we set it up on rotation XYZ. And because on our inputs we did not set it up yet, it's basically set up to 0 always. As you can see here, we are always adding the rotation XYZ to be incrementing its input rotations, which we have not set it up on Z yet, because this is going to be taking care of the shoulder movements. So if I run my other project here as a reference, and let me just... So if I put here my reference project, you're going to see that whenever I press E or Q, it's going to rotate the shoulder camera. And this is what I want to do separately for all those chain of events. If I go towards my code and I comment out this line of code here, on my reference project here, you're going to see that it has the same effect that I have on our current tutorial. And whenever we rotate, that rotation is incremented. So if we do not want to mess with math to correct this, we can simply set its global rotation to follow the ones we specify. So this is a lot more simple to deal with. So after I've commented back that line of code, whenever I run my reference project, you're going to see that I can actually select the ones we want, and it stays upright. Alright, so we have a couple of things. Let's do the shoulder thing. So for the shoulder rotations, I want a constant motion to be applied whenever we press it. So let's first detect it. So if our input is an input event key, so we're going to be saying if our input is being pressed, which is our action, and this should be our shoulder movement left first. If that is the case, our input rotations on its Z value now should be equals to 1. And if that is not the case, if it is our right shoulder command, we should be deducting this, so -1. And of course I put it upscale as always. So on rotations apply here function, let's actually add that line. So I'm actually copying this, and I'm going to simply substitute every single one towards its corresponding value. This in turn should allow us to have the shoulder movement, which we do not have yet. And of course, this is not working. Here is a bug. I added by accidentally another check for this function that if we are pressing a mouse button, which is not the case. This one right here is for the mouse zoom functionality. So now it should work correctly. So my mistake, that was something I overlooked. And as you can see right now, it works as it should. So you can leave this as it is to create an out of world appearance. So as you can see, that is how it looks. And you can set this parameter through some camera effect that slows spins up. But if you want to do a shoulder effect for a third-person action event camera, we can simply damp this value. So after and also by the way, I just tested this right here, because if you don't, it's going to be constantly rotating it up. So the way they do that is by resetting the rotations to 0, and after you press any key, it's set to 1 or -1, because the input rotations are being applied here, and we want to stop applying on its Z value. So the thing that we're going to do to damp the value is simply do a dampness check right here. So after we apply that, let's create a damp value. So if our absolute value for the rotation XYZ on its Z value is going to be higher than 0.01, we're going to say that our rotation XYZ on its Z value is going to be multiplied by 0.90. So this is equal to a damp effect. However, we want to stop calling the code if our rotation XYZ, so almost the same thing here, if it is different than 0.0, we want to basically set it up back to 0. So this in turn is going to optimize the code a little more by simply snapping it back to 0 if it's different than this value and is also different than 0. That's basically what this is doing it. So this is going to be a damp effect for the shoulder rotation. So whenever we run the game, you're going to see we run the rotation commands, and because of the damp effect, we basically stop it after a given value. So this is, of course, to create that shoulder effect we're going to be building later, that whenever we snap our player left or right. So there we go. We have now a camera system that moves towards where we are aiming and is simply rotating according to our character. The system is being decoupled, so we have a third-person camera system that is completely decoupled from the human character, so how the human character moves, and also separate from how the player is captured on its inputs. So that is the end of this tutorial. Hope you like it, and I'll see you on the next video on this series or in another topic. Make sure you are subscribed to watch the next video, and I'll see you later. Thanks for watching.